Good morning students, I am Atul Thorat from Suman Ramesh Tulsiani International School, Khamshet, and I am going to teach Science for 10th Standard in the upcoming academic year 2020-2021. So, two separate books have been prepared for Science and Technology. Science and Technology Part 1 contains 10 chapters mainly related to physics and chemistry. Science and Technology Part 2 contains 10 chapters mainly related to biology, environment, microbiology and biotechnology. So today we are going to study about the gravitation, and it is the first chapter of Science 1, Maharashtra State Board. And in this lesson of the gravitation, we are basically studied about the gravitation, circular motion and the centripetal force, Kepler's laws, Newton's universal law of gravitation, acceleration due to gravitational force of the earth, free fall and the escape velocity. Before starting the lesson, we just recall some questions. What are the effects of a force acting on an object? So, a force acting on an object causes the object to change its shape or size, to start moving, to stop moving, to accelerate or to decelerate. Second question is, what types of forces are you familiar with? So there are different types of forces. For example, frictional force, tension force, normal force, applied force, gravitational force and the electromagnetic force. And the third question is, what do you know about the gravitational force? So the gravitational force means if we throw any object in the upward direction at a certain height, the object will fall down. Why it is a fall down? Because the earth must be attract the object towards itself, and this is the gravitational force. So gravitational force means if we throw any object in the upward direction at a certain height, the object will fall down. And why it is a fall down? Because the earth must be attract the object towards itself, and this is the gravitational force. So let's start the first topic, gravitation. As we have learned, the phenomenon of the gravitation are discovered by Sir Isaac Newton. As the story goes, he discovered the force by seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downward and not at an angle to the vertical. Why do they not fly off in the horizontal direction? So Sir Isaac Newton wondered means a feeling of surprise. Why all apples are falling the downward? Why it is not fly off in the horizontal direction? After much thought, he came to the conclusion that the earth must be attracting the apple towards itself, and this attractive force must be directed towards the center of the earth. The direction from the apple on the tree to the center of the earth is the vertical direction at the position of the apple, and thus the apple falls vertically downward. Figure 1.1 on the left shows an apple tree on the earth. So in the figure 1.1 shows the apple tree on the earth. The force of an apple on the tree is toward the center of the earth, that is along the perpendicular from the position of the apple to the surface of the earth. So the force of an apple on the tree is toward the center of the earth, that is along the perpendicular. Perpendicular means 90 degree or the straight from the position of the apple to the surface of the earth. The figure also shows the gravitational force between the earth and the moon, and this figure also shows the gravitational force between the earth and the moon. The distances in the figure are not according to the scale, and the distances between these figures is not according to the scale. Newton thought that if the force of the gravitation acts on apples on the tree at different heights from the surface of the earth, can it also act on object at even greater heights, much farther away from the earth? Like example, the moon. Can it act on even farther object like the other planets and the sun? Next topic is force and motion. We have seen that a force is necessary to change the speed as well as the direction of the motion of an object. So force is necessary to change the speed as well as the direction of the motion of the object. Can you recall? So what are the Newton's laws of motion? So there are basically 3 Newton's laws of motion. The first law is every body remains in a state of rest or uniform motion unless it is acted upon by a net external force. Second law is the acceleration of an object is directly proportional to the net force exerted and inversely proportional to the object's mass. And the third law is for every action there is an equal and opposite reaction. So this is the Newton's 3 laws of motion. Next topic is Introduction to Scientist. Great scientist. Sir Isaac Newton 1642 to 1727 was one of the greatest scientists of recent times. He was born in England. He gave his laws of motion, equations of motion and theory of gravity in his book Principia. Before this book was written, Kepler had given 3 laws describing planetary motions. However, the reason why planets move in the way described Kepler's law was not known. Newton, with his theory of gravity, mathematically derived Kepler's laws. In addition to this, Newton did groundbreaking work in several areas, including light, heat, sound, and mathematics. He invented a new branch of mathematics. This is called calculus and has wide-ranging application in physics and mathematics. He was the first scientist to construct the reflecting telescope. So this is the introduction of the great scientist Sir Isaac Newton. Next topic is circular motion and the centripetal force. Circular motion means the motion along the circular path is called as a circular motion. The examples of circular motion is the hands of a clock move in a circular manner. Similarly, fan is also move in a circular manner. A giant wheel and a merry-go-round along a circular route. In our day-to-day life, we come across many examples of objects that trace a circular path. What is the meaning of centripetal? The meaning of centripetal means moving towards the center. The meaning of centripetal is moving towards the center. Hope everyone understood the circular motion and the meaning of centripetal. So try this. Tie a stone to one end of a string. Take the other end in your hand and rotate the string so that the stone moves along a circle as shown in figure 1.2a. So take one stone and the string. Tie a stone to one end of a string. Take the other end in your hand and rotate the string so that the stone moves along a circle as shown in the figure 1.2a. Are you applying any force on the stone? In which direction is this force acting? How will you stop this force from acting? What will be the effect on the stone? So as long as we are holding the string, we are pulling the stone towards us. So as long as we are holding the string, we are pulling the stone towards us. That is toward the center of the circle. And are applying a force towards it. The force stops acting if we release the string. In this case, the stone will fly off along a straight line, which is the tangent to the circle at the position of the stone when string is released, because that is the direction of its velocity at that instant of time. So this one is the tangent. Tangent means a straight line that touches a curve but does not cross it. You may recall that we have performed a similar activity previously in which a 5 rupee coin kept on a rotating circular disc flies off the disc along a tangent to the disc. Thus a force acts on any object moving along a circle and it is directed towards the center of the circle. This is called as a centripetal force. So centripetal means Centripetal means center seeking or moving towards the center point. So centripetal force means a force acts on any object moving along a circle and it is directed towards the center of the circle. This is called as a centripetal force. Centripetal means center seeking. That is, the object tries to go towards the center of the circle because of this force. You know that the moon, which is the natural satellite of the earth, so the moon is the only natural satellite of the earth, goes around it in a definite orbit. So what is the meaning of orbit? Orbit means a curved path taken by a planet or another object as it moves around another planet. The direction of motion of the moon as well as its speed constantly changes during this motion. Do you think some force is constantly acting on the moon? What must be the direction of the force? How would its motion have been if no such force acted on it? Do the other planets in the solar system revolve around the sun in a similar fashion? Is similar force acting on them? What must be its direction? So from the above activity, examples and questions, it is clear that for the moon to go around the earth, there must be a force which is exerted on the moon, and this force must be exerted by the earth, which attracts the moon towards itself. Similarly, the sun must be attracting the planets, including the earth, towards itself. Next and very important topic, Kepler's law. Kepler stated 3 laws describing planetary motion. These are known as Kepler's laws, which are given below. So Kepler's first law, which is also known as law of orbit. The statement of the Kepler first law is the orbit of a planet is an ellipse with the sun at one of the foci. The meaning of the orbit is a curved path. A curved path of the planet is an ellipse. The meaning of the ellipse is a regular oval shape or like a egg shape. Foci means focus or the center of interest. So the orbit of a planet is an ellipse with the sun at one of the foci. The orbit of a planet is an ellipse with the sun at one of the foci. Figure 1.4 shows the elliptical orbit. Figure 1.4 shows the elliptical orbit of a planet revolving around the sun. The position of the sun is indicated by S. Next one is Kepler's second law, which is also known as law of areas. The statement of the Kepler's second law is the line joining the planet and the sun sweeps equal areas in equal intervals of time. The line joining the planet and the sun sweeps equal areas in equal intervals of time. Okay, so Kepler observed that planets do not move around the sun with the uniform speed. Means planets do not move around the sun with the constant speed. They move faster when they nearer to the sun, while they move slower when they are farther from the sun. So this is explained by this Kepler's second law, which is also known as law of areas. Look at in the figure. AB and CD are the distances covered by the planet in equal time, that is after equal intervals of time. The position of the planet starting from A and C are shown by B and D respectively. The straight lines AS and CS sweeps equal area in equal intervals of time, that is area ASB and area CSD are equal. So this is the Kepler's second law. Next one is Kepler's third law, which is also known as law of periods. The statement of the Kepler's third law is the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. The square of its period of revolution. The meaning of revolution means one complete. The The meaning of revolution means one complete turn. Thus, if r is the average distance of the planet from the sun, t is its period of revolution, then t square is directly proportional to r cube. So the square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. So t square is directly proportional to r cube. That is, t square upon r cube is equal to constant, and constant we denoted by capital letter K. Kepler obtained these laws simply from the study of the position of the planets obtained by regular observation. So Kepler obtained these laws simply from the study of the position of the planets obtained by regular observation. He had no explanation as to why planets obey these laws. So Kepler have no explanation why these planets obey these laws. We will see below how these laws help Newton in the formulation of his theory of gravitation. Next topic is Newton's universal law of gravitation. Figure shows two objects with masses m1 and m2 kept at a distance d from each other. So in these two objects, the first object exerts the force on the second object and the second object exerts the force on the first object. Mathematically, the gravitational force of attraction between these two bodies can be written as F is directly proportional to m1 into m2 divided by d square, or F is equal to g into m1 into m2 divided by d square. Here g is the constant of proportionality and is called as a universal gravitational constant. So g is called as a universal gravitational constant. The unit of g is Newton meter square kg raised to minus 2. The value of g was first experimentally measured by scientist Henry Cavendish. In SI units, its value is 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. So the value of the universal gravitational constant was first measured by the scientist Henry Cavendish, and the value of the gravitational constant, that is the g, is 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. So next one is, what is the statement of Newton's universal law of gravitation? Every object in the universe attracts every other object with the definite force. So every object in the universe attracts every other object with the definite force. This force is directly proportional to the product of their masses and the inversely proportional to the square of the distance between them. So hope everyone understood the statement of the Newton's universal law of gravitation. Every object in the universe attracts every other object with the definite force, and this force is directly proportional to the product of their masses of the two objects and the inversely proportional to the square of the distance between them. Next one is an introduction to scientists. Johannes Kepler 1571-1630 was a German astronomer and mathematician. He started working as a helper to the famous astronomer Tycho Brahe in Prague in 1600. After the sudden death of Brahe in 1601, Kepler was appointed as the royal mathematician in his place. Kepler used the observations of the planetary position made by Brahe to discover the laws of planetary motion. He wrote several books. His work was later used by Newton in postulating his law of gravitation.